Hello everybody, I am Captain Mamgin. Let us start off from where we left on traverse tables. How to use traverse tables to find out our D.LAT departure course and distance. We talked about courses. I've converted into quadrant form, and quadrant form is an indication of what should be my D.LAT and departure. D.LAT is measured along the meridian, is the arc of the meridian. It's when mathematical terms is your y-axis, and similarly your departure is the arc of the latitude is measured along x-axis. 28 degrees 72 miles. If I drop a perpendicular from B or I draw a parallel latitude from B, we know that a parallel latitude cuts the meridian 90 degrees. Now what I have got in front of me is a plane right angle triangle with two values known. Using trigonometrical functions, I can find out the rest of the things here. And that's what I have done here with the course and distance. I found out my departure and D.LAT. So for the course of 28 degrees, I've got my D.LAT as 63.6, departure 33.8. And here, if you notice, your D.LAT is greater than departure. We know that the value of tan 0 is 0. So you have 0 only. Suppose you divide 0 by some value, and departure must be 0 for 0, and D.LAT has got some value. So if you notice here, if you're going on a course of 0, D.LAT has a value, but there is no departure. So up to the angle of 45, when it starts increasing from 0 to 45, you will have D.LAT will be always greater than 45. D.LAT will be always greater than departure up to the angle of 45. Because at 45 it becomes 1. So it is increasing from 0 to 1. So gradually the value of departure will keep on increasing and it will become equal to D.LAT at angle 45. And you can see here at 45, this is the isosceles triangle. This will be 45. So this side has to be equal to this. So departure and D.LAT become equal. Now for an angle of 62, which is greater than 45, I have calculated my departure and D.LAT. And now you can see that the departure is greater than the D.LAT. So when the angle is more than 45 degrees, the value of tan is more than 1. So that basically means that the value has to keep on increasing for the departure and the D.LAT has to keep on reducing. And then ultimately 90, tan 90 is infinity. So that means D.LAT becomes 0. And as you can see here, when you're moving along east or west, there's no D.LAT. There's no component north or south. So there is no D.LAT. This is important for you to remember when we'll be checking up on traverse tables. And if you can notice here, these two angles, what I've talked about here, 28 and 62, they are complementary angle, which is 9. Adding both of them is 90 degrees. And you notice here that the values have been interchanged. What was D.LAT here has become the departure, and what is the departure here becomes the D.LAT. And that, as I said, if you go by this formula of departure by D.LAT, so the departure of one angle is the D.LAT of the other angle. So that's the reason that you find that these values interchange when they are complementary angles. And this is, if you remember this, that up to the value of 45 degrees, D.LAT is always less. After the D.LAT is departure is more than D.LAT. You will not make a mistake when you're looking at the tables. That should strike you. Using the traverse tables makes it a little easier because I don't have to bother about putting up these formulas here. So this is how your traverse table looks. You have a degree here given on top, and there's another degree which is there at the bottom of the table on the same page. These tables are from 0 to 45 and 45 to 90. The top part of the table is from 0 to 45 and the bottom part is from 45 to 90. And if you notice that sum total of both these angles is 90. And that is where we are talking about when you're looking for the table from top, what is the D.LAT here is the departure here, and what is the departure here becomes the D.LAT. Complementary angles always, the thing is changing, and these tables have got complementary angles given, one on top, one on the bottom. Starts from 0, 45, 45 to 90. And you'll notice here that all the possible angles with north and south, east and west are given on the tables. Same here for 68, northeast, northwest, southeast, southwest. All possible angles of 22 and 68 are given on the same page. We use the degree as the course to convert, find out, or to find out the D.LAT and departure for the course and distance concerned. So, your course 22, you have the distance, D.LAT and departure. And you got to note when you're talking about the courses from 68, the distance are the same, but the D.LAT and departure have interchanged their positions. This part of it, we'll just talk about it to convert departure into DLONG or DLONG into departure. Now, course I've given here 058, converted it into quadrant form, less than 45, use the top 090, 292, your quadrant form 68, more than 45, you'll have to use the bottom. 248, converted into quadrant form, more than 45, use the bottom. So this is how you look at the tables here. And where to search around for 68, because you see it is very easy to see from after 20 will be 30, after 30 will be 32. But when you're looking from the bottom, it becomes a little difficult because when you're looking where is 50, where is 55. So the best way to do is whatever angle is there subtracted from 90 and whatever is remaining, and that it will be underneath, below that. Like cos 30, cos is let's say 60 degrees. Where to look for it? 90 minus 60, 30. So underneath 30 stable, you will have 60. Now this is what we had just solved using the trigonometry here, course and distance. Now let us just use the tables to find out the course and distance in the same thing here. 28 less than 45 has to be entered from the top of the table. And this, if you remember, the D.LAT would be greater than departure up to 45 degrees. We might not make some silly mistakes here when we are looking at the table from the bottom to the top. Now this is your 28 table. The distance is 72, and we get our D.LAT departure, which is the same as what we have calculated using our trigonometrical functions. Similarly, if you look at the bottom part of it was 62 because they're complementary. 62 plus 28 is 90. 62 will be at the bottom part of this page of 28. And if you look at it here now, what is the D.LAT here is the departure here, and what is the departure here from top is the D.LAT here. So when you're entering from bottom, you just got to be a little careful about the values what you have writing. D.LAT is departure. Course of 242, distance 132. I converted into my quadrant form 62. It is more than 45. It has to be from the bottom. And when I'm looking for it here, the departure will be greater than D.LAT. So where do I look for it? I said 90 minus 62. Under the page of 28 degrees, I'll find 62. 28 on top, 62 at the bottom, and the distance gain been given to me. And this is going to be my departure, and this will be my D.LAT for the course of 242 degrees. And as I said, the quadrant form gives me an idea of D.LAT south, departure, or DLONG west. Now, if required, you'll have to interpolate. Now, if suppose the distance was given to you as 132.5, so you'll have to interpolate between 132 and 133. Now, zero point 0.5 is halfway through this. The difference between this and this is zero point 0.9. So I can take half of it is about zero point 0.5. So for 62, my departure would become 117, and similarly my D.LAT for 132.5 would become 62.2. So little interpolation might be required if the distances are given to you in fraction. Of course, converted it into quadrant form. 42 less than 45, entered from top, distance 139, and my D.LAT departure. 312, 48, where to look for it? The bottom, because more than 45, 90 minus 45, 42. So it will be below 42 is 48. And the distance is given 199. Departure, D.LAT. If you're looking from top, that is where you've got to be a little careful about it. Now, knowing the course and distances, now we are able to at least figure out how to go about finding out an D.LAT and departure using traverse tables. Now, this example, if I had to find out the course, I had to find out my position arrived after sailing this course and distance, and if I was going to be solving it with trigonometrical formulas, this would be my triangle here. 125 is southeast, so my course has to be southeast here. And D.LAT departure, this is my distance given to me. Now, I can always use these trigonometrical functions to go ahead and find out my D.LAT and departure. And I've used these formulas here to get my D.LAT and departure. Now, I know the position left. I use this D.LAT here, and I can find out my latitude arrived. After this, we find out a mean lat, and mean lat can be found out either by adding both of them, dividing by 2, or half the D.LAT, plus minus half the D.LAT. And my mean lat has come to 36 degrees 02 minutes. Then, using the formula departure by DLONG, I can convert my departure into DLONG, and my DLONG is 166 minutes, which is 2 degrees 46 minutes east. And I can apply it to my departure longitude to find out my arrival longitude. So this is how I calculate my position using trigonometrical functions. Now, if I had to use traverse tables to find out my position arrived, how would I go about it? Now, my course of 125 degrees is south 55 degrees east, which is more than 45, so I have to look at the bottom of the tables. And where do I look at it? 90 minus 55, 35. So underneath the page of 35 degrees would be 55 degrees. And there I have my distance, departure, D.LAT. And if you look at it here, my D.LAT and departure are nearly the same values what we calculated using the trigonometrical functions. Now this D.LAT, whatever I have found out here, can be used to find out my latitude arrived. Now the thing is of converting my departure into DLONG. How do I convert my departure into DLONG using the tables? Now, instead of the course, what I have used this as the course, now I use mean lat. I use the value of mean lat to look into the tables now here. So my mean lat here was 36 degrees 02 minutes. Now I'll go into the page of 36 degrees 02 minutes. Being very close to 36, so I'll just stick to 36. So I'll go to page of 36, and here, what was my departure? 134.2. 134.3. This is the closest what I've got here. So my D.LONG is departure and D.LONG. So my departure D.LONG is 166, and that is what we have got it here. And this D.LONG can be now applied here to find out my arrival position. Now the problem would be if suppose the mean lat was not 36, close to 36, as we just had an example here of 36 degrees 02 minutes. If it was 36 degrees 45 minutes, then I would have to interpolate it between 36 and 37. I would have to take the mean lat between 36 and 37. And now here I will see that for the departure of 36.31, I'm getting a D.LONG of 166 and 168. So here you can see that 36, for this departure, I'm getting a D.LONG of 168. For 37, I'm getting 168. And what I require is 36.45, which is, 2/3 of the distance between this, and the difference between them is 2. So my D.LONG would become 167.5. So little interpolation would be required if you have a mean lat which is a fraction of a degree. But to find out the course and distance from this position to this position, what I've given you here. So without using the traverse tables, and if you're going to be using only the trigonometrical function, this is how you proceed. You'll find out your D.LAT, D.LONG, and convert degrees to minutes. And now D.LAT and D.LONG, as I've been telling you, that they give me an indication of what quadrant I am in. So it is northeast quadrant here. And this is how my diagram would look. D.LAT north, departure east, and this is my course. Now half the D.LAT, what I have got, find out my mean lat. So I can do it either way, either half the mean lat or add, and this is my mean lat, what I've got, 52 degrees. Now I can find out my departure by D.LONG, cos mean latitude. I've got my departure, and then I can find out my course, and after I've got my course, I can always find out my distance. So this is all I have used the trigonometrical function. So I'm not going to talk about remember any formulas, all trigonometrical functions. Now this is the course and distance what we have calculated for from going from this position to this position using trigonometrical functions. Now if I had to solve it using the traverse tables, I would have to convert my D.LONG to departure. And to convert my D.LONG into departure, I have to enter the tables for mean lat. So my mean lat is 52 degrees 45 minutes. So now, as I told you earlier, if my mean lat is a fraction of a thing, so I'll have to look between 52 and 53. So I go to the tables of 52 and 53 here. 52 and 53 here. This is my longitude, 90, and to convert it into departure, which is 54.2 here and 54.2 here, and here you have got your departure is 54.5. Now for 52.45, you can convert it like this: 1 degree 60 minutes. The difference between them is 1.2 minutes. So for 45 minutes, what will be the difference? 0.9. And your departure for 52 degrees 45 minutes using the table is 54.5. Now the thing is about finding out a course and distance. As you just saw, that conversion of D.LONG to departure is a cumbersome process. Normally, no, you all would not be doing it. Everybody would be preferring to solve it with the formula here, and you are allowed to use calculator, so there is no problems about it. So everybody can will be using this formula to convert your departure into DLONG. But I personally feel that you should still know how to use the table, so that's why I'm just giving you a glimpse of it, how to go about finding out your course and distance. As I said, you would still prefer to go and find out your course using the calculator and using your trigonometrical functions. Now, this course and distance, so what we are talking about is connected by D.LAT and departure. And as I said, D.LAT is greater than departure. Here you can see your D.LAT is 66 and your departure is 54.5. So one thing is very clear here, that if it is D.LAT is greater than departure, then I have to look from the top of the table. So the angle is less than 45. That is cleared once you've seen your D.LAT and departure. And of course, with your D.LAT and DLONG, what you have got here, you know what the quadrant you are in. So you know your quadrant northeast, and you know that the value is less than 45. So now you know that you don't have to look from the bottom of the table. So what you do next, you go to the table where you can get these values with departure and D.LAT as close as possible to whatever you have calculated so far. So your departure 54.5, D.LAT 66. So when I go to the table of 39, I'm getting that these values are close by. So now for course of 39, my distance is between 84 and 85. My D.LAT is this and my departure is this. Of course, they're not the same, but they're close. Then what I do is I go to the table next page, again try to match these figures here. And for the angle of 40, close of 40 degrees, I get the distances 86, 87 in D.LAT and departure like this. Now what basically I'm looking around for is the D.LAT of 66, not 65. Awesome. So for what distance will the D.LAT be 66 between? So it has to be between these two values. So I have made D.LAT as constant of 66. So 66 is about 0.1 minute less than this. So if you try to interpolate between this, so your distance will also be about zero point 0.1, which is 84.5, 84.9. And your departure for 84.9 would be nearly same, because the difference between them is 0.6 for 10. So zero point 0.1 will really not make any difference. So you have got for D.LAT of 66 on the course of 39, you have got distance this, departure this much. Similarly, for course of 40 degrees, I again try to find out for D.LAT of 66. Now for D.LAT of 66, again you see it is 0.1, difference of 0.1 between the what figure I am looking at for 66. So for 66 D.LAT, it's a difference of 0.1. So I've taken a distance could be 86.1. And the departure is 55.3, approximately 55.3. You can take it as 55.4 also. 0.1 difference won't make any much difference. So now what I have done is I have made 66 common in both of them. And the distances are different, departures are different. So now for the course between 39 and 36, 39 and 40, at some point the D.LAT is the same. Now the only thing is at what distance the departure is going to be 54.5. So between 39 and 40 degrees, we see that there is a point where the D.LAT will be 66, what we are looking for. Now we got to think about what distances and departure. At what distance the departure is going to be the same as this. So what I do is I have got this departure here. The difference between both of them is 1.9. Now, on which course the departure and which distance the departure is going to be this. So the difference between this and this is 1.1. I'm looking around for 54.5. That is the difference. And the total difference was 1.9. So on what course it could be possible? 1.1 divided by 1.9 multiplied by 60. This is the course, what it should be. On this course, the departure would be what I'm looking around for as 54.5. On one side of the course, which is halfway through both of them, so that would be the distance between the thing here. I'm looking around for nearly half degree between both of them. So whatever is the difference between these two, half of this, and that would be the distance. I know it's a very cumbersome way of doing it. Nobody is going to be using it, but you should be aware how to use it, and that is why this lecture I have conducted. Thank you very much for being with me.